Welcome to this next video. Today we're sort of upscaling now into looking specifically at triangles and quadrilaterals. Our learning goal is that you should be able to classify triangles and quadrilaterals, and at the end of this you'll want to be able to classify a given triangle or quadrilateral according to the different properties it has, and then apply some geometric reasoning to the properties of quadrilaterals and triangles. Alright, so we have a plethora of polygons. Now, polygon means, poly is many, gon is corner or angle. So it means things that have many corners or angles. So here's a polygon, nice little triangle for us. Here's a polygon, a weird trapezium-y sort of thing. Here is a polygon. The only things that they have other than the many corners is the fact that they have to have a finite length and eventually close back up again, okay? And their lengths have to be straight, okay? For sure. So we're going to be looking at specifically triangles and quadrilaterals. So triangles are three-cornered shapes, and quadrilateral is a four-sided shape, okay? All right. So our key ideas, so triangles are named according to their vertices and their internal angles add up to 180 degrees. So if we had A, B and C as our points there, we would say that this is triangle ABC, okay? And if we had alpha, beta and gamma as our internal angles, we would say that alpha plus beta plus gamma is equal to 180 degrees because of our internal angles of a triangle rule. Okay, that's how we work with that one. Right, as well, triangles can be categorized according to their properties. All right, so scalene triangles are triangles that have all three sides being completely different lengths. Okay, so this one, and this one, they're all completely different to each other. Okay, so that's a scalene triangle. Now we also have isosceles triangle. Okay, so same scaled triangles have two sides with equal length and two equal angles. So you've got these two legs of the triangle being equal to each other, and these angles here are also equivalent to each other. So that's the important things about our isosceles triangle. Okay, right. Equilateral triangles have all equal sides and all equal angles. Okay, so all the sides are equal to each other and all the angles are equal, and they're equal to 60 degrees because 180 divided by 3 is 60 degrees. Okay, right. Quadrilaterals are also named by their vertices, and their internal angles sum up to 360. So you have A, B, C, and D. So that would be quadrilateral A, B, C, D. And if this was angle alpha, angle beta, angle gamma, and angle delta, we would say that alpha plus beta plus gamma plus delta is equal to 360 degrees because of the internal angles of a quadrilateral rule. Okay, so that's all the kinds of different symbols you need to be aware of for this sort of geometric reasoning stuff. Okay, a couple of things we can do with our quadrilaterals to worry about. So you need to be able to figure out what a quadrilateral is, what type it is, and sort of say why according to those properties. So squares have two pairs of parallel sides. So these ones are parallel and these ones are parallel. All the sides are equal as shown, and the internal angles are 90 degrees as well. Okay, so very familiar shape. You need to know exactly why a square is a square. Okay, so for our rectangle as well, it also has two pairs of parallel sides. So these ones are parallel and these ones are parallel. Has two pairs of equal sides this time, so the opposites are equal to each other. And again, all the internal angles are 90 degrees. All right, next one is our rhombus. You might also know this as a diamond, but rhombus is a more correct term. So it has two pairs of parallel sides as shown on this drawing. All of its sides are equal to each other. Okay, so it's like a squashed square. All right, and its opposite angles are equal to each other. So this one is equal to this one, and this one is equal to this one. All right, so that's sort of how it works with our rhombus. Okay, our parallelogram. So two pairs of parallel sides as shown, two pairs of equal sides. So these are equal and these ones are equal. And our opposite angles are equal. So this one's equal to this one, and this one is equal to this one over here. Okay, so there's our parallelogram. They're all the different, that's what makes it a parallelogram other than another shape. Okay. All right, our trapezium, the only real special thing about that is that it just has one pair of parallel sides, okay? So this one, these two here, these sides here are parallel. This one and this one. Doesn't matter, they're pointing the other way. It's just one arrow. And then the sides there. Okay, so that's our trapezium. Now, last one that you guys need to worry about is a kite. All right, so it's a shape that looks exactly like a kite that you would fly in the sky, high, by and by. So it has two pairs of equal sides. So these ones here are equal and these ones here, and one pair of opposite angles, of equal opposite angles. So this one is equal to this one, all right? The other ones aren't equal at all, all right? So kites are a little bit special. You need to be careful with them, okay? Right. One last thing to worry about with triangles is this rule called the exterior angle rule. So the exterior angle of a triangle, which is this one here, made outside of it, is equal to the sum of the two opposite interior angles. So let's call this one alpha, this one beta, and this one gamma, okay? So alpha, that outside external angle, is equal to beta plus gamma because of our external angle of the triangle rule. Okay, that's a little symbol for that one. Okay, so it's a pretty important one for you to be able to know. All right, let's have a look at some worked examples. So evaluate the unknown angles in the following figures. So we've got a triangle and we need to know C. We've got 76 degrees and a right angle here. So C plus 76 degrees plus 90 degrees is equal to 180 degrees because of internal angles of a triangle. And so we subtract 166 from both sides, and we get C being equal to 24 degrees. Silly me. Maybe even 14 degrees. It's a good day. Okay, so try and put this therefore in the front too, because it looks cool and it's sort of like helping you, you're making an argument, all right? Okay, so here we go. We've got an external angle here, and we've been given the two opposite interior angles. So we say E is equal to 31 plus 44 degrees because of our external angles rule. Therefore, E is equal to 75 degrees. Okay. Lastly here, not necessarily lastly. Okay, so we've just got a random quadrilateral here, and as you know, quadrilaterals' internal angles add to 360. So we say B plus 63 plus 140 plus 70 is equal to 360 degrees because of quadrilateral rule. Okay. Therefore, 140 and 70 is 210, 273. So therefore, B is equal to 87 degrees. Okay, just better double check that. Oh, I don't trust myself. All right, if I'm wrong, tell me. All right. So we've got a kite here now. Remember, kites are special. They've got one angle opposite to each other. Okay, so you might want to actually call that, well, let's call that H as well. Okay, so you can say, actually, let's make it A. Okay, and we're going to say A is equal to H because of a kite. Okay, now you might want to just quickly draw one so I know that you mean because of the rules of a kite. So therefore, we can say that H plus 36 plus 62 is equal to 360. Okay, so let's go at 2H plus 36 and 62 is 98 degrees. Whoops, just forgetting some of my stuff here, a bit naughty. Okay, it's still equal to 360 degrees. So we're going to subtract 98 from both sides, and that gets us 262. And so therefore 2h is equal to 262 degrees. Therefore, I'm going to divide both sides by 2. Therefore, h is equal to 131 degrees. Okay, and we're all done. So there were some quick examples, some more difficult than others, but again, like our angles, ones, and transversals and points and stuff, it's all about practice, 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 and you'll be super awesome at this. Okay, thank you so much for watching, and please come and see me if there's been any issues with any way of understanding this video. Thank you.